Hello, everybody. Today we want to look into what is a PCB design. What is a PCB design? PCB means printed circuit board. Okay, so we have any kind of circuit, whether it is your home circuit, or you can any kind of electrical circuit, or any kind of other kinds of circuits. Then and you want to put all the circuits on a board. Okay, and you want to control and manage some of the switches of your home and other things. Then you can do it what is called a printed circuit board. But printed circuit board is mostly used for holding processes and some other kind of elements like capacitor, resistors, and diodes, and triodes, and valves, and things like that. Okay, transistors, and so the basic type of things that can be on a PCB board, which so first is something to do with connection. Okay, so there are something called elements and connection. Okay, elements are the thing which are going to do something for the particular circuit. Whatever circuit you give, if you have connection, then it is going to do some kind of particular work on the connection between the 2 points. It is going to resist the current, so it is a resistor, so that is going to do some kind of resist the current. And if it is going to induce, so if it is going to conduct, or inductor is another kind of thing, and capacitor is another kind of thing. So the basic circuit designs have three different types of things. One is called an inductor, one is called a capacitor, and another one is called a resistor, and you have links connecting, so the electrical circuit connection, connecting all these things. Okay, so basically there are about three different types of elements, but there are other things which are going to learn things like you have diodes, triodes. These are all called what are called transistors. Transistors are one level higher up, so they allow diodes and other things. They allow current to pass through only one direction. The other direction doesn't allow it to pass through. So these are called diodes. Triodes are like something like regulators or something like that. So which can allow current in one direction depending on the amount of voltage and other things, amount of current that is flowing through. Okay, so these are the, so there is a control element which can make the current to go pass through one side, and make the current not to pass through, so you get a zero on one on the other side. So that is the basic thing of, so a triode is the basic thing of a switch, automatic switch. Okay, where you can control the things. Okay, diode is something to do with, it will allow the current to pass through, and it won't allow the current to pass through in the other direction. That's all. So capacitor is something which is going to hold the charges for you for some time. Okay, amount of capacitance that you give, it depends on, so the capacitor is, if it's a big capacitor, then it can hold so much of charges. Why you have to hold charges? Because sometimes you need as a kind of storage of charges to to keep the voltage level at either end of the same thing, or something like that, something to do with that. Okay, so it's a kind of small time batteries which are inserted and things like that. So when you, the battery is also is another element which you can integrate into the printed circuit board. Okay, so the circuit board is just a connecting wire kind of diagram over a board or something like that. But what what are the elements that are going to go in is going to be different. Okay, so PCB design guide, understanding the electrical parameters, creating the schematic. Use a schematic capture tool to create your PCB. What is the PCB design? So that is the, what is a PCB design? Printed circuit board design brings electronic circuits to life in a physical form. So basically the electronic circuits are brought into some kind of physical form, so that you can have, so it is basically some kind of signals coming in and signals going out, or input coming in and processed, and output going out. Okay, basically, so the current can be uh, turned different manner, or voltage can be regulated, or current can be regulated in different types, and it was, and desired kind of features can be added to. Okay, design process combines component placements routine to define electrical connectivity on a manufactured circuit board. So first you have to design a kind of connectivity on a manufactured circuit board. So you have to first manufacture the printed circuit board for before you assemble the components on top of them. So first thing is there are different kinds of assembly things. One is a capacitor, another one is a resistor, then another one is closet. Okay, where you can just put in some of the processes and things like some are heating elements which can reduce the amount of heating. Some are diodes, so that will allow pass through. So the different kinds of levels of elements that can go in diodes, triodes. Then you can have PALs, okay, programmable array logic. Then you can have processes which you can go on the board. Then you have so other kinds of elements like audio signal processing unit, video signal processing unit, and things like that. Okay, so some of the things are like amplifiers. Okay, some of the things are like transformers. Okay, what are the different things that can go on a printed circuit board is these are the basic things which can go on a printed circuit board, and for that you have to print the circuit, where the circuit comes in, where the circuit, what is the input for that particular thing, and what is the output voltage for the thing, how you regulate all the things. Okay, before you design a printed circuit board, you have to do what is called a circuit diagram. Circuit diagram, you could have already done some of the circuit diagrams. Okay, circuit diagrams is the first level of testing. Okay, so once you do a circuit diagram, you connect the components in the way you want and just check it. Okay, you can do a checking of the different things. Okay, so that you will have the thing. Okay, now I don't have a diagram of the connections or circuit diagram. Okay, so the first level you have to get the circuit diagram. So once you're done with the circuit diagram, then you have to put the circuit diagram in a particular, depending on what kind of schematics. Then you have a, so what are the basics of PCB design? A schematic is the representation of component symbols and new net connections between them. Nets are the traces on the board pre-layout in the next phase in the design process, where the bill of materials from the schematics separate for long lead time components and obsolete components. Okay, long lead times and obsolete components. So they have what is called layering. Okay, so these are the kinds of structures. So the metal layer, then you have a non-conducting layer, then you have a metal layer, then you have a non-conducting layer, and then you have non-conducting layer, then you have a finally another metal layer. So these are the basic things. One side there will be connectivity, so the base thing is separated into two different layers. Okay, so here it is a two layer kind of component that is shown here. So two layers can be there. On the top there is one layer, the bottom is another layer. Both are shielded by some kind of electrical connectivity which are going to be in between those things. Okay, so in order to connect all these elements, you have to first convert them into a printed circuit board. Okay, so normal connections, you can take the wires and directly connect all these wires to different kinds of components and things like that, but that is going to be really messy. Okay, you cannot fix them onto a board and do all the things. So previously people used to make some kind of standard holes and some kind of connections, and then directly punch into the next thing which will have the connection, but the number of wires that were going in is too high. Okay, so for that they changed the whole thing into something called PCB designs. Okay, so it was just like a circuit board at the beginning. Okay, circuit board is a jumper cable circuit boards. You could have already seen some jumper cable circuit boards. Those were the right at the beginning, and later they wanted to change it and they wanted to make it as a printed circuit board, so that you don't have to do all kinds of jumping cables and all those things and connecting all the wires together and all those things. It was quite messy, so later they changed the design into a printed circuit board. Usually printed circuit boards are, if you have standard IC chips. What is IC chips? IC chips are something to do with what is called integrated chips. Okay, they do specific functions. Okay, that is why they are called integrated chips. They are integrated into the whole process of doing something is integrated into a particular chip. Okay, that is why it is called integrated chip or IC chips. IC chips are of different things. Okay, op amp is one, operational amplifier is one, TTL logic is another one. There are different types of kind of things. Okay, or audio processing, video processing unit is another kind of ICs and things like that. So each one has got separate classifications based on what is the kind of things they are doing. Okay, so you are going to have ICs, then you are going to have what component elements like capacitor diodes and triodes, and sometimes they have pentodes also. Sometimes they have other kinds of things, like transistors and so these are the basic thing. Transistors, cluster of transistors which are called ICs. Then you have cluster of memory elements which are going to be there. Then you have processor elements. Then you have signal elements. Then you have clock elements and things like that. Okay, so these are the different things. So we don't want to go into too much of details of how the things are. So first thing we want to see how we can create a printed circuit board. What are the steps in printed? Understand the electrical parameters. Create the schematic. Use the schematic capture tool to create your PCB. Design your PCB stack up. Define design rules and requirements. Place your components. Insert drill nodes, drill holes, route the traces. Okay. Then you have to check all the things. These are the basic steps of design guidelines. What are the things you have to do? First, understand the electrical parameters. So that based on the electrical parameters, you have to do the first the electrical wiring kind of thing. What are the things? How many? How much of a microfarad capacitor you need? How many number of microfarad capacitor you need? Or how many amounts of inductors you need? What kind of inductors you want? What is the value of those inductors? Okay, capacitors and things like that. So if you want to have resistors, how many ohm resistors, those things and all electrical parameters. How long the length of the thing should be, what kind, if you have a transistor, what kind of transistor you want. So these are called the electrical parameters. Creating the schematic. After that you create what is called a rough logic of the complete circuit kind of thing. What is the kind of thing, and finally what kind of output you want to have, what is the kind of input you have. Once you have this input, what is, say you have an audio coming in. Okay, then audio, so first you have a receiver kind of audio receiver, then you have to amplify the thing, so that is another circuit. Then finally you have to, once it is amplified, then you have to give it to a speaker or something like that. So these are the basic steps of something. So you get an input, so you get a transformation, then finally an output kind of thing. So it can be signals, it can be any other type of things, processing or anything. You're using a schematic capture tool to create your PCB layout. So then you have to create a schematics of how to capture tool to create your PCB layout. Okay, then design your PCB stackup. PCB stackup is one layer after another. What are the things that are interconnections that are going to be? So then you have to do the PCB stackup design. Define design rules. Okay, what the standard thing of following a particular thing is, you have to give the design rules. Okay, design rules are the requirements. So this is the kind of design that I want to do. This is the kind of thing. So this is place your components. The once you have designed all the things, then you have to place the components in proper place, which place where it's going to go and things like that. So these are the adjustments of the things you have to do. Place your components. Then you have to place all the components in the specific places and other things. Then insert drill holes. Insert drill holes means you have to drill a particular thing and connect. For in order to make the connectivity, you have to make a drill holes where the things are. How to say, if we have 2 or 3 layers, then you have to make a drill hole to connect all the things, and you have to fix the board onto something and fix the element also. So fixing element is also another thing. Okay, route the trace. Then after that you have to check all the different traces and check all the connectivity, the amount of voltage that is coming on the other end, amount of capacitance that is coming on the other end. It is all checked. So finally you check the board for all the connectivity at different traces and what is the amount of. Once you fix the components, then you have to check all the different parts and then check whether it's coming out properly. These are the basic steps. What are three types of PCBs? We can have three single-sided PCB, double-sided multi-layer PCB, rigid PCB, flux PCB, and rigid flux PCBs. So these are the different types of flexibility. So single-sided PCB, you have one side, completely metal kind of thing, and all the circuit is on one side only. Okay, so that is single-sided PCB. That is all the wires we have it on one side. Okay, and the components on the other side, then it is called a single-sided. But double-sided PCB, you can have things on either end. Okay, so part of the things is going to over the top, and there is a second layer which is also going to help you to place the components on top, but those those two things are independent. Okay, but you can interconnect those two layers also inside. That is called double-sided PC. Multi-layer is you can have any number of layers in between, and each layer has some kind of circuit. Okay, each layer has run these multi layers can be interconnected using what is called holes, or direct connection, things like that. Okay, so rigid PCB is something to do with, it's not flexible, you cannot bend it or something like that. So those kind of things are all rigid PCB. Flex PCBs are a little bit flex in the sense, like you can stick one over the other, those kind of things. A little bit of flexibility is available, so that it's just passing a bus wire or something like that. Those are all flexible kind of things. Flex PCBs, rigid flex PCBs, partly they are partly to do with rigid and partly to do with flex. In PCB design is good career. Okay, some of the designing is a good field with much opportunities for skill teams and career opportunities. So basically, it is something to do. If you can do it good PCB design, you could be hired for some kind of hardware manufacturing and things like that. Usually, so simple PCB, you will see how to design a standard simple PCB. Okay, design the printed circuit boards. Okay. So this is the kind of thing that we want to do later, but right now we don't have all these things. This is a PCB design kind of thing. Okay, so the circuit looks somewhat like this. Okay, so you have to use a designer. Okay, what is a designer you can use for doing a printed circuit board? So this is basically a routing kind of the process and art about saying. So this is something to do with, this is the kind of look where the inside of the thing. So the blue one is the bottom or something like that, and green one is the first layer, and the yellow one is the second layer, and the whole things are all the connecting holes and holding elements and things like that. So this is how it looks like when you through some of the things. Okay, the number of layers gives you the different kinds of things that is going on in each one of those layers. So this is a schematic overview of number of layers going in. Okay, each color represents different kinds of layers. So single layer, double layer, triple layer, what some of the useful components, thicker connectivity path, and a thinner connectivity path, and things like that. Okay, so this is how you do some of the PCB layout designs. Okay, now we go into PCB design. PC. Okay, so this is the one which wanted to show you. Okay, so this is how. So some of the things that have what we call ICs, integrated circuits. These integrated circuits look somewhat like this: 1, 2, 3, 4, 5, 6. Here it has 7 pins on one side and 7 pins on the other side. So this is 7 4 kind of ICs. Then you have resources. Then you have symbols like in the sense whether it is a variable resistor. So those kind of things are done here. Okay. So when you have something like so symbols. Okay. So these are the basic things that you can have: resistor. Okay. Capacitor, inductor, diode, transistor, logic symbol, switch symbol. Okay, so these are the basic things that can be on the board, which are higher elements. So logic symbols also can be there. So the logic symbols are like NAND gate and things like that. So NAND OR gate, exclusive NOR gate and things like that. So these are the connecting levels. So logic symbols are the one which you can use it for a specific kind of purpose. Okay, so directly you can just make the thing. So resistor symbol is somewhat like this. Capacitor is an inductor is Diode symbols are like this, transistor symbols are like this. Okay, transistor usually has 3 pin kind of thing. Diode has two things, which looks like one side it is dark and the other side is a light kind of thing, and say D. So inductor symbols has got. So let's do. So this is called a fixed resistor, potentiometer, rheostat, LDR, and thermistor. Okay, thermistor is something to do thermal transmission. Rheostat is something like variable kind of thing. Okay, variable resistors. LDR is something light emitting diode kind of, so light potential variable resistor. Then potentiometer is going to do the variable of the voltage of the particular thing, not amount of resistance. And fixed resistors are the one which are standard used. Okay, so we go back. So capacitor symbols, there are four types of capacitor symbols: non-polar capacitor, polar capacitor, preset capacitor, variable capacitor. So preset capacitor is fixed onto particular kind of thing, and the capacitor value is fixed. Variable capacitor, you can change the capacity depending on whether you can just keep on changing the thing as in. So it has got a capacitance value of different. Okay, polar capacitor is something to do with, it is going to be some capacitance is going to be polarized on different kinds of non-polar capacitors, standard capacitor that you are going to use. So any kind of capacitor comes into non-polar capacitor. Okay, so these are the non-polar capacitors. This is how they look like. Okay, so it's a blue thing which is kind of thing. Then we have smaller elements like this. If you want, there are two things for a capacitor. Okay, so positive and a negative. So these are called, so these are non-polar capacitors. You can connect it on either end, I think. That is why it is called non-polar capacitors. You can make it positive or negative depending on which side you connect. So it can be positively on one side, positively charged on another, negatively charged on. So non-polar basically has something to do with the alternating currents or the AC kind of thing. So usually AC things are usually used for non-polar capacity. So this is how the elements look like. Some blue element which then you have smaller dot things. Then after that you have some bigger ones. Then you have smaller bulk ones. Then 104K, 250JS. This is another kind of the bigger capacitors which can hold. Then there are other kind of capacitors that you can come in. Okay, this is the non-polar. Polar capacitors, we'll see. Polar capacitors are something to do with, you can connect it through one thing, plus or minus you have to give. So the voltage has to be plus or minus or another thing. So if we connect to a, say you are connected to a DC or something, the plus thing should be connected around, say the now the thing. So that is for AC, so this might be for DC or something like that. Okay, this is how they look like. So you have to know. So when just directly go connect all the things, then you you buy capacitor 16 volts and 107 something like that. So 16 volts is the polar capacity. So 16 volts is the one which you can connect. So those kind of things are there. So polar, non-polar. Then we have preset capacitor. Preset capacitors are like this. Okay, preset capacitors are fixed kind of capacitor which are variable, but right now they are used as a kind of fixed kind of thing. So the capacitance value is some kind of fixed. Okay, these are variable capacitor. So variable capacitor is the one which looks like this. Okay, preset capacitors, they are also the preset capacitor is the same as variable capacitor, except that it is fixed onto a particular constant value. So it is a kind of switch which is used inside. Okay, so variable capacitor, these are the things. So we go back. So we have finished resistor symbols, capacitors. So resistors can be in ohms. What are the different ohms? So it depends on fixed resistors. So fixed resistor can be look like this. Okay, they look somewhat like this. Okay, so fixed resistors, you see symbols like this, some kind of lines on the kind of thing. These lines represent whether it is 100K, so the next one is 50K. So if you add both the things is 150 ohms. Okay, so this is 150 ohms resistor, this is a 200 ohms resistor, this is a 220 ohm resistor, 120 ohm resistor, this is 1764 ohm resistor, this is a 30K ohm resistors. Okay, 30 K ohm. Okay, So they give you the heat specification. Different types are there. You can use one of them. So this is 0.030 ohm. Okay. So if the resistance power is extremely low, then you have something like a flat structure. Okay. So if they have, but if you have end to end kind of like some kind of leads, it's going to be higher resistance power kind of thing. Okay. So higher resistance. So this is how they look like resistance. So some of them are, if it is thick one, then it is 30 kilo ohms. Okay. High resistance powers are all given by like some kind of green symbol, and still higher ones are given some kind of blue symbol. Okay. And the lower ohms, so like 10k, 5k, all this 350k, 20k, 1k, or things like that, they are going to be a bit smaller size. And 0.5k and things like that, they are going to be a little bit smaller. Or 0.3, 0.1k or something like that, those are all going to be a lower side. Okay, so that is how the fixed resistance. Potentiometers are going to be like this. Okay, so because it's a variable kind of thing, the resistances can be varied. So depending on whether you turn it around this side or that side, it can be varied. So there are other types also. Okay, so they have 3 pins also. Sometimes the center pin can be connected to something external, or current can be changed in that, so that you have a variable resistance on the either end. So there's one type of this. There's another thing, rotating type, where you have to do it manually. This can be, some of the things can be done automatic, some of the things can be manual to do a variable resistance kind of potentiometer. Okay. Then you have rheostat. The rheostat is usually some kind of long thing which you have resistance coming in. So it is a kind of a huge thing. Okay, usually quite large resistance kind of thing. We have to do a LDR. LDR looks like something like. Uh, so it senses the, depending on the amount of light that is coming in, it is going to increase the resistance. Okay, so if you flash light on it, the resistance is going to increase. If it is going to reduce the amount of light, then it is. So mostly if you use the camera or not, these are the things that are used, light limiting. It's a kind of LDR symbols kind of things which are going to use, and that is night vision camera and things like that. They are going to use these kind of things to find out the different kinds of amount of energy that is coming in. Okay, LDR thermistor another one which is going to be. So this is for thermistor which is going to produce some kind of heat or something like heating elements and other things. Those kind of things are all. These are called thermistors. Okay. So this is also resistors. Okay. So they are going to generate quite a bit of heat for those. So based on the heat that is coming in, it is going to resist higher. So if you give too much of heat, then it is going to resist higher level, and if it is lower temperature, then it is going to reduce the amount of resistance. These are called thermistors. They look somewhat like long things where you can. So if you have a thermistor, then you can say if you have a temperature on your oven about 30 degrees centigrade, so 50 degrees centigrade it should switch off. So it should increase the resistance value. So these are called the thermistor symbols. These are the things which are used in sensing some of the temperature kind of thing. So these are called thermistors. Okay, so these are the basic things of resistance. Okay, now we have uh, resistors. Capacitor symbols we already saw. Okay, then we are going to inductor symbols. Inductor symbols are like this. Okay, air core inductors, fixed trapped inductors, iron core inductors, ferrite core inductors, solenoid inductors, variable inductors, adjustable inductors, some practical inductors. So these are the things. So air core inductors, how it looks like. Let's go into air core inductors. Probably it's not available. Okay, but anyway. So this is how it looks like. Air core inductors look somewhat like a coil like thing and coming down. Okay, there is just some kind of hole will be there. There will be a small winding of wire. So that is called air core. There's another one is also right here. That is also air core. So then we have fixed trapped inductor. Okay, fixed tapped inductor. Tapped inductor is like something like going on coiling, and then suddenly you have a small tap inside and then coming out. Okay, so you have tapping outside, then it's called a tapped inductor. Iron core inductors, they'll the center they'll have some kind of iron. Okay, the coil will have the center some kind of iron. So these are the iron core inductors. So when you see some of the things at the bottom on the right, bottom on the right hand side of the bottom, so those are called iron core inductors. Okay, so they can be adjustable or non-adjustable. So iron core inductors are something like the which is the one which is used for standard kind of inductors. Okay, so first ferrite core inductors are the ones which are usually used for any kind of AC circuit design and converting into DC, those kind of ferrite core inductors. Solenoid inductors looks about like this. They have a some kind of uh, some kind of structure, and then after that that whole thing is going to spin over. So these are the ones are so a variable detector is going to be somewhat like variable kind of thing. Adjustable detectors or so these are the adjustable. So the last one looks like the adjustable, and before that it's a variable detector. Then your variable does. So these are the solenoid. It's mostly standard when you see anything. Okay, solenoid inductors will be the one which is used. These solenoid inductors are the one which are going to be used even in other kinds of for inducting purposes and other things. But if we go into IC circuits and other things, the first one which will be the air core inductors will be the maximum that is used. Fixed type inductors, the next one it is used. Okay, there only in special occasions you can use the other type of inductors. Okay, diode symbols. Okay, conventional diode. Okay, so these are called the conventional diode. Conventional diodes look somewhat like this. Okay, so there is a small thing which is going to be, if we want to use ICs and other things, then the smaller one is used. If you have a bigger kind of current coming in, then you have higher elements. So still further it is going to be higher element, and still finally you have if you have a huge voltage kind of thing, then it is going to be used by the different kinds of, so 5 volts, 7 volts, they are all specifications based on the voltage and rating. Okay, so how much of current they can take, how much of voltage they can take, and how much of energy that is going to be used. Okay, so so you cannot use high energy kind of supply kind of thing on, because the current is high, then some of the diodes might burn out, or just burn out or something. So you have to use a lower current rating and some voltage rating and things like that. So you have to look into voltage and current rating, and with some of the things you have to check for the diode frequency rating, also some other things. So these are the conventional diodes. Then you have LED type diodes. LED type diodes, some required, so they just blink on the thing on the board, depending on, they emit light. Okay, whenever you, so if you want to have a small circuit for your home board, then you can connect some of the LEDs. Okay, on the printed circuit board. So you have a serial of 10 LEDs that you can connect. Okay, all of the same voltage rating and other things. If then you give a small voltage of battery, you connect a 5 volts battery, and you find a 5 volts LEDs, and you connect them all in serial. Sometimes you can connect them in parallel, and then check some of the circuit boards. So you can create a circuit board for connecting them in serial. But these are all small things. When you have, so, if you want to make a torch light or something like that, then you can do all these things. Okay, so this is the kind of LED store that you can have. So a printed circuit for a torch consists something like that. Okay, LED. Photodiode is a kind of one which is going to do a photosensing. Okay, that is in the sense light sensing. Okay, so whenever it senses the light, immediately it acts, it kind of disconnects the circuit. Okay, disconnects or not disconnect, it doesn't allow current to flow through another thing, and depends on what kind of luminosity and what kind of voltage it can work on, what kind of things you have to, the current value it can take, and those things you have to check in. And these things are usually used for sensing. Okay, so if somebody is going on the street and you want to sense the person, then these things are used, photodiodes are mostly used, and these things are, like if you have in a dark room and somebody is opening the door or something like that, you can photosensing. Okay, a car opener, when you open the door of the car, light is coming and immediately can sense those things. Those kind of things are used for photodiodes. Scooty diode is some kind of special kind of diode which will just break circuit breakers, mostly something to do with circuit breakers. If you want to do any kind of design any kind, so you can use Scooty diode. Schottky diode. It's called Schottky diode, so it's a breakthrough circuit as well. Tunnel diode. Tunnel diode just allows the things to pass through once it is got reached a certain level of voltage level. Then, once beyond that particular voltage level, then it is going to just tunnel the current through. Okay, diode works one level only, but beyond a certain level, it's going to just tunnel through on the things. Zener diode is another one also. So this is also different types of diode which is going to use. So it will just make the circuit. It will just make the circuit break, or not circuit break. It will just start connecting the things. Depends on what kind of things it is coming in. So you can go look up what is Xenon diode do. Okay, diode which is going to use it for most probably I still don't remember what is Xenon diode, but it is a diode which you can use it for special purposes. Okay, it is going to, once it reaches a amount of current level, then it is going to, the current is going to pass through. That is why it's called Xenon. It mostly kind of so tunnel diode and Zener diode, these are the two basically. Schottky diode. So these are all special type of diodes. Photodiode or LED diode also. So normal conventional diode is going to be just blocked. Okay, and LED, the same thing, blocking happens, but if there is any kind of current, there is going to be light that is also going to be given out. Okay, they will allow current to only pass through one side, and it will give current whenever the circuit is completed, those kind of things. Okay, so these are the different kinds of diodes you can use. Okay, now transistor symbols are different, NPN, PNP, JFET N channel, JFET P channel, these kind of things. So gated P channels, gated. So when you're using all the circuitry board, you have to know which are the components that you have to use and for what circuit purpose and things like that. So those things is quite a huge area, and you have to first check all the signals and other things. But anyway, we look into some other parameters so that you can have an idea what is happening. Okay, some real NPN transistors are like this. So NPN is negative, positive, negative. Okay, so you have to give a negative voltage on the C and E elements, and B is the base which is going to do the control. Okay, so you have to give a positive voltage on base and two negative voltage on either end, and so you can give it on earth. Okay, so based on what is going to give it, so they usually have three things. Okay, so the center one is for the base, and either side of the thing is for N. Okay, negative. It has to be given a negative voltage on either end, and base the cut of the things. Okay, this is going to be used for transistors, mostly used for what, regulating the current to pass through on one side, and depending on what is the voltage given on the base, it is going to cut off the particular circuit. That's all. Okay, so base is some kind of switch kind of thing which is going to control switch kind of thing. That's all. So this is for NPN, and then you have PNP transistors which are going to be somewhat like this. Okay, depending on what is the, so you have positive kind of thing on this side, so you have to give positive on C and E, and you have a base which is going to be N, so you have to negative bias kind of thing. So negative bias things are going to be, so JFET transistors are going to look a little bit different. Okay, JFET N channel, so D, then you have a S and you have a gate. Okay, so gate, you have to give a positive voltage on the gate to do all the complete thing. Okay, so this is for used on higher voltage kind of thing. So usually JFET and other things are all going to be working on higher voltages, like you have your DC AC circuit, AC for 50 to 20 volts AC and things like that. So they use these kind of higher order things. Okay, if it is going to be a alternating current which is of lower voltage, then the other one set of things will be JFET P channel is the same thing except that it's positive kind of thing, so it is going to be used as a reverse voltage. It depends on the kind of voltage so circuit is going to be completed. So these are the kinds of things you can use. Okay, so JFET N channel, JFET P channels are all going to be in higher order circuits, and NPN transit, PNP transit are lower voltage kind of things where it is going to be used, or number of cycles and other things dependent on this. Okay, so these are the transistor symbols. Then when we have logic symbols, okay, OR gate. Okay, so if you look at an OR gate, this is OR gate. Like we have two things, A and B input, and we have the binary output depends on what kind of input you get. Okay, this is an OR gate. This OR gate symbol is these are all symbolic representations. So they, you whether whether circuit, this is for circuit symbols. Okay, so you have to use them by using the transistors for circuit symbols, AND gate and other things. Okay, XOR gate and NAND gate. So the basic symbol circuits are OR and not gate, NOR gate, NAND gate, XOR gate and XNOR gate. Okay, exclusive OR, exclusive NOR. Okay, not and not OR, not just the NOT gate. So OR AND is the basic thing. Then you can do a NOT of those things. So NOT OR is NOR. So NOT AND is NAND. Then you have OR gate. So XOR gate, exclusive OR gate. So OR gate. So you can NOT of that gate is exclusive. So OR and exclusive OR. Okay. So these are the three basic types with the NOT. Okay. So R is inclusive and XOR is exclusive OR. So the R types are two types. Okay, and is only one type. XOR is R is two types. One is inclusive OR and exclusive OR. Inclusive OR is instead of IOR you can just write OR, and exclusive OR is XOR, and not of all these things are going to be there. So basically 1 2 3, so 3 into 3 into 3, so it's good, 3 into 2 types are, so totally about 6 different types are there, and not is one of them, so totally 7. Okay, so if we look at login symbol, there's just going to be 7 symbols. Okay, switch symbols. So these are the different kinds of switch you can use. Okay, on and off right at the board, and button switch kind of thing. That switch timer kind of rotary switch can be there. Switch flip switch can be there. Double circuit connection and double pole. So open switch is something like that. You can just close switch. Okay, this is a simple open switch is like this, close switch. Single pole double through switch. Okay, so there is one single pole, and you can if you turn on one side, the circuit is to be connected on the other side. If you turn on the other side, it's going to be connected on the other side of the circuit. So this is single pole double through switch. Double pole double through switch, so we can connect two of the things on a push button type. So you just push the button, you can make the connection. Push button closed. This already the circuit is closed, but if you push button, you can create an open circuit. Float switch is something like that. You push it on this side, it will be connecting on that side. If it is connected on this, then it will just disconnect. Thermal switch is kind of like if your heat is coming in, then based on the heat sensors, you go to connect or disconnect. Multi switch is something like that. If you keep on pushing, it will go to the next. Those are called multi switch. But rotary switch is completely circular kind of thing. Some practical switches. So rotary switches are basically used. So they are rotary switches and all, it can be used for the circuit. This is for circuit connection kind of thing. So these are the things which is resistor, capacitor and other things. Okay, so these are the different kinds of symbols we saw. We kind of now we go into ICs. Okay, what are the basic IC types? There are different kinds of ICs. 7400, 7400, 7401 and things like that. Okay, So it is basically a quad 2 input NAND gate. So basic thing is 2 input NAND gate is the one 7400. So quad 2 input NAND gate, which is going to be 7401. Okay, 7401, except that it is going to be reverse side. Okay, so if it can be in forward side or it can be on the reverse side. So that is why they are given in a different kinds of things. So both are NAND gates, but for one thing is the other side of the, so you have to give the ground on one side and other things on the other side. So depending on the NAND kind of positive or, so 7402, okay, quad 2 input NOR gate. So you can give two inputs. Okay, basically you can give, it's a NAND gate, then this is a NOR gate. Okay, so 7402 is a, first is NAND, the NAND is two types, then we have NOR is two types. Okay, so 7402, 743 is 3 is two input. Basically they all have ICs already have two input only, two input and two output, I think. Okay, two input and how many outputs are there? Two input kind of structure. Okay, hex inverter. Hex inverter is a kind of things which is going to invert the thing. So there are about 6 diodes kind of thing. So 6 NOT gate or something like that. Okay, 6 NOT gates. This is a hex inverter. Okay, so it is going to hex inversion of the things. Okay, but exactly what is this, a NOT or a something like that. Okay, so these are just going to invert the things. Okay, so this is a kind of inverter, that's all. Okay, hex inverter 75. Then we have hex inverter buffer driven, so they have buffer driven of inverter. These are all different types of ICs that you can use, that is why buffer driven. These are buffers driven. 7408 is quad 2 by AND gate, so the AND gate is 748. So the first one is 7400, that is for NAND. Then we saw NOR, then we have AND starts from 7408. Okay, so basically calculations, if we look at all these symbols, they look almost similar, but only thing where how many, so 1 2 3 4 5 6 7, so 7 pins will be there on one side, 7 pins will be on the other side. So you have to identify depending on where the ground is and things like that. So which side is forward side, which side is backward side. These are all standard steps used, because you need 5 AND gates, 4 AND gates, then immediately you can order for 7408. Okay, if your requirement is AND gate, 4 AND gates, then you can use for. So gates are all coming in, where gates are all coming in only chips or ICs. So you cannot buy gates like that. Okay, so the normal things like uh, the, if you want to buy as a group kind of thing, NAND gate, AND gate, or OR gate, something like gates and all are about bought only on a IC chip. So that is why we have all these IC chips. Okay, so the different things doing different things, 7413, 7411 and things like that. Okay, so you can go have a look at all these different IC chips, how many inputs, how many outputs. So these are the different kinds of, these things are used depending on what kind of requirement. So you have to find the right IC to do your circuitry in case of, if you are doing any kind of logical circuitry. Okay, any kind of logical circuitry. So if you want to do clock also, you have to take an EC. So flip flops are all clocks. Okay, so if you want to generate any kind of clocks, you have to get an IC. Okay, which is going to work on lower level kind of thing. Okay, 7476 and 7473 are the flip flops. Okay, then another one is edge triggered flip flops also there, which is 7470, 7400. Okay, the basic thing that will be doing for for input output and the input kind of thing, you will use 7440. And if you want to edge trigger something like a JK flip flop or trigger based on the edge kind of thing, then it is good. If it is not edge triggered, then it is going to do a JK flip flop. This is for clocking. Okay, so this is two kind of things that is available. So JK flip flop The same thing JK flip-flop with a clock or something like that. So you can give a clock also inside. Those are edge triggered kind of thing. So it has to be triggered by edge. The other one is normal clocking. The other one is edge triggered. Another one is dual 4 input NAND buffer. Okay, dual 4 input NAND buffer. There are other circuits which these are the basic circuits. Clock for the thing. Flip flop is usually for use for clocks. Okay, and 7476 and 7473 are the most useful thing. 7470. So 7470, 7376. Okay, these are the basic thing used for in case of any kind of timing things are needed and flip flop is needed for ICs. Okay, so these are the things which you are going to. Now if you want to go into resources, then you can go into PCB materials. Okay, different kinds of resources are available for a particular kind of. Where are the resources available? High speed differential via. Okay, so this is high speed differential via. Okay, what is the kind of thing? Okay, through wire standards. Okay, these are BGA. Okay, now wire rating cable. So what are the wire ratings? So the different kinds of wires you can have wire ratings, diameter this much. So this is 11 millimeter wire thickness. Okay, these are the gauges. Okay, resistance is about low and the current is how much maximum current it can take. So these are the gauge you can give. So if you want to print a circuit board, then you have to say how much is the size of the lines that are going to connect. Interconnect lines are going to be there. So there are about 40 different types and higher types also. Depending on what kind of component you are going to place, you have to use the gauge size also for connectivity. Okay, that is for AWG wire rating table. Okay. Through wire standards is drill finished. Okay, tolerance, pad straight, wire type, anti-pad, solder mask. So these are the kinds of things. Through wire types is just kind of standard high density wire. So if you have high density kind of things, then you can have drill finished as 0.012. So 0.012 is the other one and things like that. So these are the standard kinds of plus or minus 003, plus or minus 003, and these are tolerance, pad size. So these are all pad size, the sense like anti-pad RD. So these are called the drill types. Okay, wire type is the sense from one circuit to another circuit, if you are going to connect, that is called a wire. Okay, so if you are going to place an IC over another kind of socket, then it is called the wire type. Okay, wire standards. High speed differentials. High speed differentials is what? This is going to be ground plate and pattern or things like those are the schematics for the kind of things you want. Okay, PCB material dielectric constant. So if you want to do dielectric constant of the PCB, so PCB has got different kinds of dielectric constants, high resistive kinds of polyimide. So if you have medium kind of thing, G Tech. Okay, these are the Delco and other things are all low things are all standard. Okay, so they have standard FR1 Nelco, ice low. These things operate in dielectric as 4, 3 and 4.2 and things like that. Depends on last target and cost. So cost is low for a normal thing. Okay, and they work in the range of 2.5 gigahertz to 2 gigahertz. So if you go into high level processor and all, then you have to go into medium type or high type. Okay, if you're going to use processor and all, it is going 10 gigahertz and things like those kind of high level processor or IC high tech processor. Then you have to use medium level or high level. Low end kind of thing, then you can normal circuit. Okay, you can use low PCB medium. Okay, PCB material type. SMD resistor package. Okay, resistor package is type with length and watt. So there's the size of the thing is the one which is, so you have to specifically say that I want this kind of size of the resisting material. So the wattage is also given 160, 160, 110, 1/8, 1/4, 1/2 and 1. So for complete heating kind of thing. So wattage is 1 watt kind of thing. So amount of current or the power that is going to be dissipated as you keep the resistance is going to be. So the length and the width are the kind of thing. The type is also 2512 and things like that. Okay, these are the resistor packages. SMD packages, capacitor packages. So these were capacity packages. Then we have a standard resistor package, IC packages, material dielectric concepts. So what kind of material code? So IC package itself, we have to specify all the material classifications and all. So you can specify the exact kind of thing. Material dielectric concepts is what is the kind of material you're going to use for dielectric concepts between the PCB board. So component placement guide. Then there is another one is called component how to place the guidance for the complete part. So PTH component pad stack, non-plated pad stack. So first thing we look into a simple circuit. Okay, so I wanted to show you a simple circuit how to do things. Say you want to convert convert you know what are the transformers. Say you want to do a transformer. Okay, so you want to design a transformer. So what are the things that are needed for a transformer? First you have to convert the alternating current into direct current. Okay, so that is the kind of transformer. A transformer is not, yeah, basically it's going to do the thing. So first thing, you need a big huge coil kind of thing, and that component will be what somewhat like a inductor component. Then after that you take four diodes and place them as a kind of square kind of thing. So you place four diodes as a kind of order kind of four square kind of thing, and you allow current to pass only one through. So you have to place the diode in such a way that the thing goes on, and then you have to give the capacitor to come out of charge and just things like that. So if you take a simple kind of uh, thermistor or something, we don't want to go into thermistor circuits and other things. A simple thing is a transformer. What does it do? It is basically taking an IC current input and converting the whole thing into a DC. Okay, so how will the waveform will look like? So if you have a sine wave kind of thing which is coming in, okay, for an alternating current, okay, and depends on frequency and things like that. So DC, if you want to connect to DC, all the negative part of the sine wave will be inverted. That's all. So we have a DC, and there will be a cutoff thing which you can use it for the resistance capacitors. Then finally you can get the thing as a uniform kind of, say, 5 volts or 7 volts as the DC that is coming out of the other end. So this fluctuations, you have to have a inductor kind of circuit which will do the not too much of variations that is coming in. So the voltage will be regulated at the other end as a kind of direct current will be there as pi or 0.5 volts or something like that. So this is a kind of 5 volts or something like that. So you are actually converting a 220 volt alternating current with an amperage and things like that, and finally you are going to convert the whole thing into 5 volts DC circuit. So these things of converting into finally into a DC of 5 volts is required for for your lower components for your audio component, your speaker, or your other kinds of things, or lower circuitries that you can use, ICs you can use and other things. So first they convert into alternating currents of higher voltage, higher rating and higher frequency, and getting into a lower kind of, so that you have a 5 volts DC at the other end. Okay, so how they do it is a whole process. Okay, that is why they use all the printed circuit boards to do it. So processor and all are higher components which we don't, ICs and other things are all higher components which we want to do. So first we have to get the diagram done. Okay, so for a converter, okay, AC to DC converter, okay, or what is called a AC DC converter, then you have a standard circuit that how you have to draw and find out all the different components, what is the voltage requirements, everything, and based on that you have to assemble all the things on different the circuit board. First you have to draw the circuit, then you have to find the what kind of parts you can have for that. So you can have different kinds of ratings for this. So a diode which is going to use 220 volts kind of thing, and it has so much of things, then you have to get those kind of diodes. You cannot get an ordinary diode on a low voltage kind of AC. So it is going to be a 5 voltage AC, which is about 220 volts, means you have to convert the whole thing into 5 volts DC, means it's a in a specific kind of circuitry you have to buy. So on what kind of things you can use, what kind of resistors you have to, what kind of capacitors you have to use, those kind of things also. So if you want to see a simple kind of what circuit will look like, we